In today's video, we are going to learn about some classic and modern encryption techniques. Now, learning about encryption, it is one of the important part of digital security, where it is very much necessary for identifying threats, if any, and also to safeguard your system and devices from any online or offline threats. Now, we'll see an introduction to encryption. Now, since ancient times, there have been an encryption messages used for sending encrypted messages or secret codes across the world, where it always began with a simple substitution cipher which was used in your ancient civilizations. Then came the world wars, where the military saw a need to somehow send encrypted message such that the enemy could not find it, and so it drove to an development of the more complex of encryption methods. And right now, in the digital age where advanced algorithms are there, we are able to secure the digital communications and data alongside it. Now we'll see some olden days classical encryption techniques. Well, not olden days, but of course it's still being used now. Now, first one being the substitution cipher. Here we replace each letter in the plain text with another letter or symbol. Now the plain text in this reference describes the message or word which you are trying to encrypt. And next one being the transposition cipher, where we rearrange the overall order of the letters itself in the plain text without actually changing the letters. Next one being your polyalphabetic ciphers, where we use multiple substitution alphabets to encrypt the plain text. Next one, we have the most used Caesar cipher. Now here we have three parts of it. First one being to shift. Now the shifting means to move the letter across a particular shift value. Now example, select a number to shift the alphabet. Example, shift of 3. Now, in case in this image here, if you say to shift D 3 to 3 shifts, it will shift 3 and it will go across G. Then similarly, here we replace each letter with one of the appearances in 3 positions later. Now this is in case of shift 3 only, and that depends how many shifts you want to do. Next one, to decrypt its message, we need to reverse the process by shifting the letters back to its original position. For that, you need to know how many shifts were done in this case. Now the classical example being for shift of 3, you can just reverse it to get your original message. Now we'll see some advantages of Caesar cipher. First one being that it was very easy to implement and use, and was very much good for shorter messages. And as of now, it is good for educational purposes. Now some of its disadvantage being that it was very much vulnerable to brute force attacks, meaning multiple tries will eventually get you the original message. Now that's what. Speaking here, frequent analysis can easily break it. That's the point which I said. And it is not much suitable for sensitive information. Next one, we have the substitution ciphers, also one of the mostly used ciphers. Now we have mainly 3 types of substitution ciphers done. First one being the simple substitution, where we replace each letter of the word or sentence with a unique symbol or another letter. Next one being the homophonic substitution, where we replace each letter with its multiple possible symbols to obscure or jumble up the letter frequency. Now, next one being polygraphic substitution, where we replace your group of letter itself with another groups or symbols. Now, for this, you need to have a graph of the letter to or let's say you need to have a word list to easily able to decipher it, and also you need to understand the frequency in which it was changed. Now we will see some advantages being the large key space. Now, since the English alphabet has 26 letters, you have a very much large key space to adjust your frequency on that. Next one, that it can be very complex. Yes, even if a single mistake can lead to a whole different message, or maybe to error up the message, but it was very much customizable. Next one, its disadvantage that it is vulnerable to frequency analysis. Frequency analysis in this term meaning how many times a letter or word, no, especially letters, has repeated in a word or sentence. Next one being that it is very much time consuming, especially for longer messages. Well, this point may not be true for the current modern era because algorithms can easily make it up, so not so time consuming. Next one, now we'll begin with some modern encryption techniques. First one being the symmetric encryption. Here we use same key for encryption and decryption, which is fast, but the key sharing is risky. Now here you have a separate key which is the same for both your encrypted and decrypted, but the problem here being the key itself is very critical. An example being the encryption for your disk in the system, where you get a encrypted code which can be used to both encrypt and decrypt your drive. Next one being the asymmetric encryption, where we have two keys, namely the public and private key pairs, which are both used for encryption, but the key exchange can be intensive. Now here the public key is generally shared along with everyone, whereas the private key remains the same. The next one and the latest being the hash functions, where we generate a one-way function that is generated in a fixed size of output, and it is mainly used for integrity checks and passwords. Now this is similar to the automated generated passwords which you generate by various softwares. Now there you can generate a fixed length of password being 6 or 10 length max. Next one, some standards of encryption. Now here we will see about AES encryption. Now here we have some steps to do it, or let's say rounds. First one being the key expansion, where you generate a series of round keys from the cipher key. For this you need to have a cipher key first, which then later will be used here. Next one you have your initial round, where you perform add round key operation with the initial round key which was generated. Next one we have your main rounds, where you repeat the sub byte, the shift rows, and then mix of columns and the round key again for multiple times. And in final round we perform the shift rows and add round key without any mix of columns. And that's how AES key encryption works. Now we'll see some advantages and disadvantages of this encryption technique. First one being in advantage that it is very much stronger for not known practical attacks. Meaning unless the enemy doesn't know your format in which you have done it, it is very much stealth. Next one being that it is very much faster to make in both of software and hardware methods. And next one that it is very much widely adopted and scrutinized. Now one example can be some devices which are I think you might have heard people saying that this is AES encrypted drive. So those are that. Next one we have some disadvantages, and one of them being that the key management can be very complex. Now here, since multiple keys are generated, So it's very much hard to remember the right key for that. Next one, that it is very much resource intensive for low power devices. Yeah, that's true, because since you're generating multiple keys multiple rounds are done, low power devices which do not have much processing power may be at a disadvantage for that. And that's it for this video. I hope you liked it, and thank you for watching.